All right. So amines are generally considered weak bases. They're definitely more basic than OHs. And the main thing is that they're not acidic. Can you rip a proton off ammonia? Yes, you can, but it's very hard to do. We've seen some N minuses, and every time we have, they've acted as very strong bases. Meanwhile, taking an H off an OH type of group, like such as water, is relatively easy. And this has to do with the fact that oxygen is more electronegative. Now, oftentimes I see students kind of doing some very kind of confusing things, and I think I found one of the roots of confusion in terms of when we're talking about amines and when we're talking about their pKa values. So let's just review again. A pKa value is how strong an acid is. And the lower it is, the stronger the acid. But what we're talking about amines here are bases, right? Amines act as bases. So we don't want to be talking about pKa's. We want to be talking about pKb's. The B just stands for base. And a pKb is just a measure of how strong a base is. And again, the lower that this value is, the stronger the base. However, we generally don't talk about pKb's. They're just not used. Anytime you're having a conversation about whether something's acting as an acid or a base, we always just use pKa's. We don't use pKb's. And the reason that we can use pKa's is because for an acid-base conjugate pair, the pKa and the pKb are equal to 14 when you sum them up. And again, this is of an acid base conjugate pair. So instead of talking about things in terms of pKb, oh, this has a really low pKb, that means that it's a strong base. What we instead say is that its conjugate acid has a high pKa. So the higher the pKa, the stronger the base, right? So a big pKa is equal to more basic. And here's where the especially confusing part of this is. So if we type into Google, something like ammonia pKa, and it doesn't have to be ammonia, it can be pretty much any amine group, any nitrogen containing group, it's going to give us a value, right? And so according to Google, the pKa is about 9.3. If we think about our pKa values, that's not very large. And we just said big pKa is equal to basic. A 9.3 is not very large. So does that mean that amines are not basic? And furthermore, for example, something like water has a pKa of 14, right? So water has a bigger pKa than ammonia. Does that mean that water is more basic? Or that ammonia is more acidic? And the answer is no. No. And here's where the problem comes in is that amines are amphiprotic. And when we're talking about the pKa's of amines, or when we're Googling the pKa of amines, we're not actually talking about the amine. We're talking about its conjugate acid. So for example, when you type into Google ammonia pKa, it does not give you the pKa of ammonia. It gives you the pKa of ammonium. So for example, if NH3 picks up a proton, it becomes NH4 plus. And that's when you Google, that's what it's telling you the pKa of. It's giving you the pKa of the conjugate acid. This pKa is equal to 9.3. So a protonated amine is slightly acidic. Ammonia itself, NH3, to try to deprotonate this and make this an NH2 minus, if we take a look at the pKa value of this proton, it's about 38, which is a large number, which tells you that this proton is not acidic at all. Well, not at all, but not acidic. So pKa's of amines are often listed as the pKa of the conjugate acid. And this has a special term. It's called pKaH. However, most places won't even say that it's pKaH. They're just going to start talking about pKa's and assume that you just know that actually they're talking about the conjugate acid. So for example, if you try to type into Google triethylamine pKa, you'll get about 11 as your result, a pKa of about 11. Now let's take a look at triethylamine. There it is right there. Which one of these protons are acidic? Absolutely none of them, right? There are no acidic protons on here. They're all carbon-hydrogen bonds. And carbon-hydrogen bonds are not acidic. So when we're Googling and we type in triethylamine pKa, it's not giving us the pKa of triethylamine. It's giving us the pKa of the conjugate acid, right? This has a pKa of about 11. That is slightly acidic. This does not have anywhere close to a pKa of 11. It is not acidic whatsoever. So very confusing, but that's just the way it is. The basicity of amines is useful, though, for solvent extraction. So basicity of amines, useful for solvent extraction, right? And we've seen that in lab, right? If your compound has an amine in it, you can add some kind of acid, you'll protonate it, and now it's ionic. It'll go into the aqueous layer, and then thus you can separate it from the organic layer.